All right, with the sun still shining on me. Welcome everybody to Astronomy Daily Live. Hope everybody's doing well out there. Grab your favorite consumable of choice. I've got the HOH again, the hydrogen hydroxide here. So I've got a nice full mug. I almost forgot to fill this up. Almost. So, but I got back in time, and here we are. So, I hope everybody's doing well. Cheers. Hmm. All right. So let's look and see who's in the chat so far. Okay. Very good. Yeah. Atta posted a little note over on the Discord server saying that it was kind of sort of clear at her location. So she has pulled out her telescope and is out uh, doing the telescope thing. So that's exactly how it's supposed to be. That lady has her priorities right. So yeah, if it's a choice between uh, going out and making some cool observations, be it with an optical telescope or a radio or whatever. Um, it's always best to go out and explore instead of sitting here listening to some weird guy chit chatter about all things astronomy. So yeah, so she is doing exactly the right thing. So yeah, okay, well, cool. Hope everybody's doing well. The sun continues to set. It's still lighting the place up here. So while it's lighting up my place, it's already pretty dark where you are, huh, Bobby?
Oh yeah, it sure is and stuff.
Yeah.
Please ought to start doing the bird thing, like in one of the vacation songs here in Louisiana.
Well, she is.
Yeah,
She's off. She's off doing the telescope thing. So
yeah.
that's great. That is very great. All right. Well, yeah, I think everything's good here. It's actually clear here. So what I'm going to do tonight.
Well, here's a Tom Bad Scholar.
Oh, is there a Tom in the chat?
Yep.
Cool. Great. Um. So 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 yeah, it's definitely going to be clear here. So at 9 p.m. local time, my local time, I'm going to go outside and I'm going to determine whether I'm going to be able to observe this near Earth asteroid. What'll be Sunday night for me here. It looks like there's a possibility that it's going to be clear. So so that means I want to at least have a chance at it, because it's going to be pretty faint. It's going to be pretty faint, um, and it's going to be moving really fast, like very fast, so fast that if I did like a 5-second exposure, I would actually see a streak caused by its motion. So I can only do like 2-second exposures. And this thing is going to be moving at about, I think I calculated it was something like a quarter of an arc second per second. So it's definitely going to be moving really fast, and I'm going to try to observe it for about an hour or so. So it's going to be it's really low. It's something like 22 or 23 degrees above the horizon um, when I start, And by the time I end, it's going to be like, really low, really low. So it's going to be an interesting challenge. But tonight's thing, because it's clear, I'll be, briefly going out and scoping it out to see if I can actually, keep the telescope where I normally have it, and be able to see this region of the sky. So I think I can. I think I can. But if I have to move it, I want to know that now. So I've got a little bit of time to make some changes. Um, so all right. Well, cool. All right. Well, that is what is going on in my little world. So cheers. Hope everybody's doing excellently out there. Things are good here.
Mm-hmm. Prost.
Ah,
Mm-hmm, baby.
fantastic. Yeah, there. I don't think there's anything really more refreshing than an ice cold one of these, right? It just can't be beat. Can't beat it. In terms of refreshment, if your goal is refreshment, this is it. Um, if it's something else, then that might not be it. All right, well, cool. So yeah, that is the plan. The asteroid it has a number. I I think it's 66391. I think it's about a 1.4 kilometer diameter near Earth asteroid. Um, and it is going to be passing by us, something like 11 or 12 times the distance between the Earth and the Moon. So pretty far out, right? A couple of million miles out, a few million miles out. So it's not really close, but at its closest approach, it's essentially as bright as it's going to get as well. And this thing is supposed to be like magnitude 12.5 or so. But this asteroid is interesting because it is rotating. And over the course of an hour, I should be able to see part of that rotation, part of it at least. I think it's something like a 2.9 hour period or so. So I'm not going to get all of it. I mean, if I get an hour, I'm gonna be lucky to get an hour. Um, but one of the other interesting things about this asteroid is that it has a moon. It has a smaller body that is going around it as well. So it's a pretty crazy thing. There's absolutely no way that I'll be able to see that moon. No chance, no chance at all. Um, it's way too small, way too close. So yeah, no way to see it. But I will be able to get a light curve. I think. So we'll see how it goes. It's going to be moving fast. It's going to be moving really fast. So hey, I wanted to alert everyone to an interesting event that is taking place at Jupiter right now. Right now, apparently, or within the past couple of days. Um, and I just found out about this just prior to going on to the live stream here. So let me get that up. Yeah. So here I'll let's see. I'll share my screen. I always like to share my screen. hide that away. So this is what? Spaceweatherarchive.com. I don't think I've ever heard of it, but these pictures are pretty interesting. So here's what they saw on May 19th. I guess this is 1810 Zulu. I guess I guess that's how I would read that.
Yeah, that's it.
Okay. So look at the red spot region. This arc thing here. This is really unusual. This is really weird. Really, really, really weird. So that's what everybody's excited about. Is this is the red spot is usually just this round red spot, right? But now it's got this thing here, and I guess it's moving upwards. I'm not exactly sure. We can look at the article here. Yeah, they're calling it a plume of gas, stretching more than 10,000 kilometers. So, yeah, just kind of interesting. I don't know what this is. This is a okay. So they saw sort of a similar thing back in 2017, I guess, too. Okay. Anyway, just wanted to alert those who are observing Jupiter these days that yeah, something's going on. Something's going on up there with Jupiter, and well, it will definitely be monitored. Uh, right now, I think Jupiter is rising about like around 10:30 p.m. local time or so, wherever you are. It's rising about then. Um, so it's you still have to sort of wait up, right? Because I mean um, you've got to wait for it to rise, and then you have to sort of wait for it to get high enough in the sky. So that's at least another hour. At least another hour. So
Tom Van
you're
Star said it would be amazing if the giant red spot dissipated in our lifetime.
it would well, this is why I wanted to alert everyone because we don't know what's happening. We don't have a clue. So yeah, this could be the beginning of the end. It could just I mean, who knows? It could happen this one time and never ever ever be ever
How
observed
did
ever
the
again.
red spot came around in the first place?
Oh, I can't understand you at all, Bobby.
Oh, how did the red spot came around in the first place?
It has been observed as long as humans have been observing it. So yeah, I think it was first seen. I don't think I don't think that Galileo saw it. I think somebody after him saw it. Maybe Tom knows who first observed the red spot. But
It
for as
has been seen for over 400 years.
yeah, it's I mean, it has been
So,
it's been around as long as we've been observing it.
yeah.
But,
So even when apes started to come around, that giant red spot was there, right?
even when what?
Probably when we were just evolving, I guess that giant red spot's been around. around,
Oh,
right?
I no, I don't think so. I think this is a well, I think the going theory is that this is a short-lived, relatively speaking, a short-lived storm that is not going to last. That does have a lifetime. It's just, maybe hundreds, maybe thousands of years. So I mean, but we don't know. We don't know anything at all.
So it looks like nobody has the ability to take the red spot, right?
To to what a red spot?
Nobody sent a probe, or we don't have the technologies yet to take the red spot yet, right?
Well, we do have a spacecraft there. It's the spacecraft Juno, and it does target the red spot from time to time. So
But I don't think. Does Juno has the ability to date the red spot? How long it's been there?
yeah, the only way to try to do any kind of dating at all is to create some kind of model, and that model could be completely wrong. So so yeah, there's no way to, you know, like observe this and say, it's this old. No, we have absolutely no way of doing that. We would have to put it into a model, um, and then make some guesses.
So, so not bad for that red spot to be there since its first discovery 400 years ago.
Yeah, yeah. You know, it's been around at least that long. We have observed it, changing. Actually, recently it's been shrinking. It's been getting smaller. So, is this sort of the next phase in it vanishing? I don't know. And as I said, maybe it's a
Mm.
thing where it happens once and never ever happens again. So who knows? Who knows? But this is a pretty big plume. It's a pretty big plume. So yeah, I'm sure that this will be thrown up on social media all over the place. Um, so yeah, definitely check it out. Watch the progress. Pretty interesting. Pretty interesting. It's both exciting and a little unnerving to see uh, relatively big events like this. Yeah, that's a pretty massive something. Pretty amazing.
Maybe I can go check to see when Jupiter's gonna rise. At
It should rise right about this time of year. It should rise about 10:30 your time.
okay.
So I think you might. What do you have, another hour, or do you have another 2 hours until 10:30? I think you're 2 hours, right?
I'm about 5 hours behind UTC.
Right. So you're 1 hour.
If I'm not mistaken, I think it's about to come up right soon enough.
Yeah,
Let me
I think you might be an hour out, isn't it? Isn't it 9:19 there p.m.?
uh
9:20.
yeah, 9:20.
Yeah. So you've got. I think maybe you have another hour. I'm not sure.
Well, actually, I'm gonna. Jupiter will emerge from the horizon at 9:36 local.
Oh, 9:36. Okay. All right. So pretty soon.
Yeah. Yes.
Pretty soon. Cool. Cool. And that goes for everyone around the world, more or less, give or take a few minutes, depending on your latitude. So, but yeah, well, cool. So, yeah, I just wanted, to let everybody know that something's going on at Jupiter, and it might be interesting to go take a look. Um, I'm trying to think if there's anything that I'd be able to contribute. Um, so yeah, I'll be thinking about that. I'm glad I found out about this because you know we can make some observations maybe and see if we can I mean, if nothing else, collect some data and pass it on to you know to those who can make some sense of this stuff. So pretty cool. It's a nice image too. Really, really nice image of Jupiter.
Ganymede in Europa is gonna be around.
Yeah, yeah. There are websites that predict when the Great Red Spot crosses Jupiter's meridian, the central thing here. So you can probably look that up. I have to remind myself where to find that, but yeah, I think if you do like a Google search for um, Great Red Spot Meridian, you'd probably get there. So give that a try. Pretty neat, pretty exciting times at Jupiter. Don't know what's going on there, but I'll
I
definitely.
wonder if Radio Joe has a live stream of Jupiter's endeavors.
Um, Not that I'm aware of. Not that I'm aware of. No,
Hmm.
that
I
would be
think it'd
kind.
be everybody's radio listeners' dream to actually capture Jupiter and stuff.
Oh yeah, yeah. I would think so too. I mean, the signals that you get are a little weird, right? I mean, you have to be able to know how to interpret them. Um, but once you get past that, oh yeah, observing Jupiter is just uh, um, that's just one aspect um, of radio astronomy. So Jupiter is really 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 bright in the radio. In fact, so so yeah, yeah, you could definitely go from there. So anyway, very cool. We got some action on Jupiter, so keep an eye on that. I mean, if nothing else, keep an eye on the news because that's that's uh, that's a pretty serious event there. Um, I mean, that almost looks like it's casting a shadow, you know? So pretty interesting. It'd be really, really interesting if Juno um, could take a look. But I would think that they're on a pretty tight um, orbital schedule. So, they may not actually go over the red spot for, years. So who knows? Who knows? I don't think that they're. I don't think that they're too capable of changing their orbits. I don't think that that would be a good idea. But hopefully, some close observation might be able to be made. But yeah, this looks massive. Yep, absolutely huge. All right. Well, let's see. I'm looking in the chat. Tom's still in. Very good. Excellent.
Yeah, silent chat tonight.
The silent chat. That's all right. That's all right. I've got to keep my throat.
Saturn's rings disappearing will also be a big deal.
Yeah, that's don't know what's going to happen there. Oh, I've got a fantastic sunset outside. So wow, some nice colors out there. Saturn's rings are also an enigma. So nobody really knows how long they've been there. They were,
I think Saturn's rings been there since the solar system formed, right?
well, nobody knows. Nobody knows. We only know that they have been around as long as we've been able to observe. So that's only it's only a few hundred years. So yeah, we really have no idea how how long Saturn's rings have been around and how long they're going to last. We don't know that either. Just like the red spot, it's the same answer. We have no idea. So, and we can guess, right? And we think that we've made some pretty good guesses, but yeah, guesses are really hard to make.
Yeah.
So who knows, really? So, but yeah, I mean, Saturn's rings, could vanish in a very short amount of time, and so could the Great Red Spot. I don't think that we understand any of the mechanisms involved, none at all. The best that we can do is just sort of observe and catalog this, and we're starting to do that, which I think is a good thing because we'll at least have the data to be able to, go back to re-examine, reprocess all of that, to see if there are some answers that we're just not currently seeing. So hopefully the data is good enough to do that. But yeah, that's a pretty good shot. I'd like to see a lot more of those. So pretty cool. Pretty cool. All right. Well, I was looking at some of the references for Gamma Aries, that binary star that we were looking at yesterday. And one of the references sort of caught my eye because it is talking about a observatory that's very near me, and that is Mount Graham. So yeah, so on Mount Graham there is the Large Binocular Telescope, which is a telescope that has two 8.4 meter mirrors. There is the Vatican. I think it's about a 1.5 meter telescope. They're up there, And there's also um, submillimeter telescope up there, the SMT. So they're up there, and they are actually just to the north of me. I can actually see the LBT dome from my house here. It's a big white spot right on top of the mountain. It's a big, huge eyesore up there. So I was just kind of curious as to why this reference was in this list, because this is a list that is supposed to have references that talk about our object here. So it's like, well, what are they doing with Gamma Aries? And it turns out that it was actually one of the stars that was used to make these measurements of the quality of the sky. And so yeah, they did that, and they actually used Gamma Aries along with a few others here. Where's the list? There it is. So there's Gamma Aries right in front, and they also looked at a few others. And these binary stars, these are all binary stars. This is what they used to measure things like seeing and other atmospheric parameters. So here's the separation between the two components. It looks like they sort of chose components that were relatively close in magnitude to each other. You see how these numbers aren't too far off, right? I mean, this is a little bit off, but they're relatively close to one another. So that probably has to do, well, I don't know what that has to do with. Because the color of the star would make a little bit of a difference there as well. So maybe all these stars are basically the same spectral type as well. Not sure about that. But anyway, so yeah, in order to evaluate the quality of the atmosphere on top of Mount Graham, they used this star as one of their measurements. And yeah, they came back with some really, really nice numbers. So this seeing value here is 0.72 arc seconds. That's really, really nice. Anything around 1 or less is considered really, really good. So this isoplanetic angle of 2.5 arc seconds is the you can sort of imagine it as a like a piece of the sky in which all the light sort of travels in the same direction. So it's very, very small, very, very small. And the wavelength coherence time has to do with this size and the velocity of the air. So this is just how long an image will stay stable. And in this case, it's 4.8 Oh, I think that's microseconds. I think that's microseconds. I don't think that's that. Well, that might be milliseconds. I think that's got to. Yeah, that's got to be milliseconds. Sorry. So that's pretty fast, but not as fast as it is elsewhere. Relatively speaking, this is a long period of time. Um, what is that? Point 0.048. Oh, no, 0.0048. Right? Times 1,000. Yeah. So 0.0048. Inverse that. So that's like 208 hertz. So that is pretty fast. But anyway, so yeah, I just the Mount Graham reference caught my eye, and I was like, okay, well, what are they doing with this? But yeah, they're just measuring the quality of the sky. Now, for sure, there is a difference between the quality of the sky up there on Mount Graham and the quality of my sky. But except for the elevation, we're pretty much seeing the same air, pretty much. So these are nice numbers. I like to see them. Very cool. All right. So what is happening in chat? It is just a quiet chat tonight. All right. Interesting. A nice quiet chat. Everyone is just blown away by the quality of the production here. All right. Well, cool. Let's we can actually keep going with that, because I was just looking at all the references here. Let's see. There have been a few more of these speculointerferometry from the Naval Observatory. There have been a few more of those. A lot about the Hipparchus mission. So that was the predecessor to Gaia. And see, here's some more speculointerferometry. Every few years, they came out with some new speculointerferometry. Let's see. Okay, so why would this paper be in this reference list? This is talking about Mercury. Looking at it from SOHO. So why is that in here? Maybe they used that star as a reference or something. Maybe it was in the field of view. Well, let's find out. Curious. Curiosity is a great thing. Oh, but I don't think we're going to be able to see it. Not fair.
Yeah.
Let's see if there's another way in. Come on. Oh, he's not. He's not.
Sure, you're
doing
clicking
it.
on it?
Yeah, I am, but nothing's happening. I think it's because I'm already here. Yeah, dang. How else can we get to that? Let's see if we can just We'll do it this way. See if it's here.
Here comes stubborn cosmic.
Gotta be stubborn. Oh, dang it. Man, that's not fair.
Somebody get the Texas tail razor.
That's just not fair at all. Come on. Man, what do we have to do here? Sign in required, it says. Well, let's see.
Might pay for it.
Yeah, there's a paywall. Stupid.
Yeah.
Ridiculous.
Stupid.
Ridiculous. Look at that.
Retarded.
That. They want 36 bucks for a paper. Forget it. We already paid for it. All right. I'm not going to go off on my rant about that, but yeah, we're not going to be able to.
He should open the door for. Makes you think that he should be accepting donations. Yeah, well, grumble. Just weep and get gnash and just.
Well, I do not like to be beaten like that. That's the worst part. Okay, well, we will never know why this paper is in this list. We just will never know, and I don't care. At least not that much. HR diagram. Yeah, see, here's all the Hipparchus stuff. Linear polarimetry of AP stars. Oh, man, I don't remember what an AP star is. All right, so okay, that's kind of interesting. So yeah, I guess somebody published this, the Chinese Astronomical Almanac, and this is a correction to that. Boy, they really messed up on a lot of stars there, didn't they?
Man,
it's pretty funny.
How did you seriously? How did you mess that up?
Well, maybe corrections is, I don't know, the wrong term to use there, because maybe they just improved their measurements, so they had to change them, right?
Probably using the wrong system.
Well, that seems like a lot, so I don't know. Let's see. Micrometer measurements of visual double stars. So this is somebody back in 1986 measuring separation and what's that?
I was T-minus 1 year.
Oh yeah. And let's see. Well, 58th name list of variable stars. That's kind of interesting.
Yeah.
Measures of double stars.
We should have those French articles? Makes you think we should get a translator.
Yeah. Well, that's all right.
But sadly, I don't know anybody that does French.
Yeah, I don't either.
Well, I'll take that back. Someone in another room knows French. Should know French.
Somebody in the room does?
I was in the other room in my house, but not only that, but Jill should know as well. Because he speaks French too.
Cool. All right. Well, it looks like that they've known about this being a binary star for quite a while. So pretty cool. All right. Well, let's where were we? I don't know. I think we were here. Yeah. So we're back with Aries, constellation Aries. And yeah, we were just looking at Gamma here a little bit. So at least according to Wikipedia here, there's a bunch of double stars. Okay. Let's see. Yeah, just sort of, regular run-of-the-mill stars here. Can't say as I can see anything too exciting. B3 stars, K1 star, F2, A0. Oh yeah, there's a what they call a runaway star. These are stars with a very high velocities. So 53 Aritis. So yeah, it doesn't say anything about how fast. So let's find out. 53 Aritis. We'll go back to Sinbad. Let's see if we can just do this. So it's calling it a variable star too. Huh. I don't know.
Hey, there's Kira. Kira H.
Hey there, Kira H. Nice to see you in the chat. Glad you could stop by. So we're looking at 53 Aries, and at least according to the Wikipedia, 53 Eritas is a runaway star, which my understanding is that it's supposedly moving very, very fast. But looking at the Sinbad entry, it's not. Its proper motion isn't. I don't know. That doesn't seem very, very much. And its radial velocity being 21.7 kilometers per second. Is that? I don't think that's very fast either. Maybe it is for a star. Yeah, I guess I'm not quite sure. Not quite sure.
I wonder if Sinbad has an Android app.
Oh, I don't know. I don't know. Yeah, you'd have to poke around, see if there's anything. Wouldn't it be too hard, to do something like that? Oh, here's a.
Yeah, sadly they don't.
I'm not incredibly surprised that they don't.
So Thomas, though, is it the same as a rogue star?
Oh, I don't know. That's a good question. Yeah, I don't know. There's a lot of terminology, right, being thrown around, and yeah, I'm starting to get confused about some of these terms. So yeah, I'm not quite sure what the difference is between a runaway star and a rogue star. I don't know. Anyway, here's the image of 53 Aries uh, with the Sloan Digital Sky Survey, release 9. So again, it's overexposed. That's all right. And there's a little galaxy right there. It's nice. There's another one back here. So, but for the most part, I'm seeing stars. I'm seeing lots of foreground stars. Pretty cool. Couple of galaxies here. Here's I don't know if it's hard to tell what this thing is. Um, it's probably too faint to really see any diffraction spikes. Maybe we're seeing diffraction spikes on that. You think that's a star? It's really
No,
hard. Yeah, I don't know.
they're not the same. Runaway stars are not to be confused with rogue stars, which,
Okay.
although also feel the need for speed, having been flung completely out of their home galaxies.
Oh, okay. Okay. So rogue stars are stars that are potentially from other galaxies, where runaway stars, I guess, are from our own. Is that the distinction there? Um, yeah, I don't know. And I'm also not sure if that's a star or a galaxy there. I think it's a star. This is definitely a galaxy. But, you know, unfortunate for us
Yeah, I
both.
think uh, maybe in a future show we'll have a deeper comparison of runaways and rogues.
Yeah, we can look into that a little bit. Anyway, so there's a nice galaxy there that nobody cares about. Nobody will ever even think about. Sad but true.
Sad, sad, sad.
Sad but true. Nobody nobody cares about the little galaxy there. Nobody does. It's just out there, you know, hundreds of billions of stars in a little tiny patch of the sky. Totally insignificant. Isn't it great?
Yeah, probably something that they forgot.
Yeah, it's amazing. What an amazing place we're in.
It's a beautiful
Very,
place.
very amazing. We need to,
Just wish we don't have a. I just wish we don't have that light pollution thing. I think the only
well,
way we can avoid light pollution is just turn everything off.
I I just wish that there was a way that we didn't have to fight as much as we do, and uh, uh, just enjoy ourselves a little bit more. You know?
Yeah, just like shortwave. I know, like I was listening to a reporter week one time. He was in New York, and one time he was able to listen to shortwave, but the next time he went, he wasn't able to.
Oh wow.
Yeah, because the reason why they installed those new energy efficient. street lights, and it definitely messed up his listening game.
Oh man. Yeah. Yeah, it's I you know there definitely has to be some kind of compromise, right? I mean, if you're going to be living in the middle of the city with a lot of people and all of that, there are certain things that you're probably just not going to be able to have. And one of those things is a very, very, very dark sky. You just aren't. It's um and it's just because there are a lot of people there that need to be able to see at night. I mean, that just makes sense, right? I mean, um, even if it was the safest place ever, you still want to be able to see where you're walking, right? So you don't trip on something. So we need light.
Yeah, that's it.
Yeah. So
Yeah,
so so
it's
I don't like this.
So when I was living in Cross Springs, I was you could just go like out the town about a few miles away, and then you might be able to get something out of it. Because
Yeah,
Cross Springs
yeah,
is a very very small town in the middle of nowhere.
I see. Yeah, I think
Yeah,
I mean, if you live in the city, if if you either choose or you have to live in the city, then there are just certain things that you're not going to be able to do. And one of them is to see a dark, dark, dark sky. So let's try to keep the dark areas as dark as we can, um, because that helps us all. Those
yeah,
that are here, and those that come out here, because there's a nice dark sky. It helps us all
yeah.
to keep the light down, right? You don't have to be shining it up all over the place and all of that. Uh, you know, be
I think
reasonable,
yeah.
right?
Yeah, that's right compared to like living in a tri-city area where I'm at right now.
Hmm.
Because the tri-city in my parish in Louisiana consisted of four areas. There's Patterson, Bayou Vista, Berwick, and Morgan City.
Wait, it's called the
It's
tri.
called a tri-city, but there's four areas. The reason why it's called a tri-city is because Bayou Vista does not have a corporate jurisdiction,
I see.
but Patterson, Berwick, and Morgan City does.
I see. Okay. Yeah, it's just, those are those weird things, that we humans can wrap around our heads with no problem at all. It's Tri-City, but there's four components. It's like, man, that's a mind twister.
I know it's mind-boggling too.
Yeah, that's funny. All right. Well, I am noticing the time, and I'm noticing that it's almost in less than a minute. It's going to be 3 hours UTC. So yeah, let's what do we call it for today? Um, tomorrow will definitely happen. Just like I said yesterday. See, isn't it amazing? There's a good probability that tomorrow is going to happen as well. So I will be here. I'll be here.
Tomorrow,
Tomorrow.
I
Yeah.
love you. Tomorrow, you always a day away.
Always a day away. Yeah, it's amazing how that works. You can never actually get there. No, as soon as tomorrow, you know, becomes today, then it's today. It's not tomorrow anymore. Dang. All right. Well, I think it is time to go. So it's 3 hours UTC. Yeah, I'm going to go out probably in about another half hour or so, and see if I can spot the area that this object is going to be in. Hopefully I won't have to move around. So we will see. We will see. All right. Well, for now, I'm going to
Yep.
get out of here. I don't think I forgot anything else. No, I think we're good. I think we're good. So let's do this again in a spin. In a spin, I will be here. More astronomy, space, science,
Yeah.
nerdy things, all kinds of great stuff. So, all right, everybody, take care. Peace, cheers, and all that. Live long and prosper. And I will see you later. Okay, bye.